everyone, welcome to another episode of MLOps Coffee Sessions. I'm Vishnu and I'm here today as usual with Dimitrios. How you doing, Dimitrios?
What's good? How you all doing?
Happy Monday to you, Dimitrios, and to our guest, Jacopo Tagliabue from Coveo. Thank you for joining us, Jacopo.
Thanks, guys, for having me. Nice pronunciation, by the way.
I try my best.
Very good, very good, very good. 9 out of 10. Very good.
He put on his famous Italian accent and he said your name.
I honestly wish I did have. I could do a passable Italian impression. It would be awesome. Make my life a lot more fun. We are very happy to have you on, Jacopo. Your content and your work lately has been making a lot of waves in the MLOps community. Whether it's the posts about what MLOps at reasonable scale looks like, the DAG cards concept, which I saw got published at a workshop at NeurIPS, or just your template repos. We've been seeing repeated instances of people on our Slack mentioning it, asking questions about it, and we are so grateful to have you on to talk about all this cool stuff and your work at Coveo as the director of AI. Thank you for joining again.
Yeah, thanks again, guys, for having us. And, thanks to everybody listening to this for spending time on this instead of Rick and Morty season 5, I guess.
So I want to kick things off and really kind of get into the idea of MLOps at reasonable scale. It's a great, very interesting title. And I know you gave a talk on it at the Stanford MLSys seminar, which we'll link to if people want to check that out. But can you tell us what it means and how you got to sort of that term?
Yeah, absolutely. As a field, both as research and industry, if we're also into it and immersed into it, that it's very hard for us to see a very strange phenomena when it comes to educational material and sharing and all the topics of discussion that we have usually. My metaphor usually is this one. It's like, as a field, we're all trying to learn how to play tennis, but the only thing we discuss most of the time is Roger Federer training, which is awesome and super inspirational. But A, we're really starting to play tennis. B, even among ourselves, the people that at the end of the training are going to be, Roger Federer level, they're going to be very, very few statistically. Otherwise, everybody would be, right? And this is what kind of happens with ML and MLOps in many cases, as in we spend months of our time discussing what Uber, YouTube, Google, and Facebook do. But at the end of the day, we're just trying to put our first model in production. Like many of us literally have still the problem of going from a notebook, to a model that, that serves prediction at as I say, at reasonable scale. And so I think there's a gap there, not that this is a market gap, but an idea gap of like things that we should discuss together with inspirational stuff from YouTube. But there's a lot of things we should discuss that actually apply to the vast majority of practitioners, especially the one that comes to the field now. Because let's face it, the people that are practices at Google, YouTube, and Facebook and whatever, they kind of already figured all this out. Like you never heard people at Facebook saying, we can never go from notebook to production. Like nobody ever said that, right? But everybody else does. And so the idea of our series with my dearest colleague and friend, Andrea and Ciro, is, well, we did this first as our company, TUSU, that they're going to acquire by Coveo. But also Coveo is a company that is reasonable scale. We did this, we know how to do it, and we can help other people seeing how easy it is to do ML thanks to this, this incredible MLOps ecosystem that we have right now. And the reasonable scale kind of encompasses two things. It encompasses constraints, as in, of course, people at reasonable scale cannot, hire or the people that Google hires or have petabytes of data. But it comes with advantages. Because at the end of the day, nobody's asking you to build an ML system for 2 billion users. It's a reasonable request at the end of the day. You need to build a recommender system for an e-commerce making $100 million a year. It's a challenge, but it's a reasonable one, okay? And it's so reasonable that right now, again, thanks to this ecosystem, you can use off-the-shelf tools to build your pipeline and kind of achieve incredible results that just 5 years before would have required, 10 people just to get started. So when we do all this evangelization and things, it's about communicating this enthusiasm and this optimism of like, hey guys, we can do it. If we did it, you can do it. And here is our, somewhat opinionated, self-deprecating, full of humor, a way of how you can build this pipeline. We can disagree on tool A and tool B, but this recipe really works at reasonable scale.
That it makes perfect sense. And I just wanted to say, I think what you're describing when you're talking about that reasonable scale concept is why the MLOps community exists and why it's thriving, and in a short plug for us, why we went from 3,000 people in January to 7,000 people, in November. It's like there are so many people at companies that are, at the reasonable scale that are solving, similar challenges, that are having organizations that are adopting ML at the same time, that, it's really given us a lot of life. And I think it's why your piece has resonated so much. And I really like the way that you define, the constraints and the advantages. It helps give a better sense of who the kinds of consumers or the kinds of participants in this discussion are. Demetrios, I know you had a question. What were you thinking?
I just want to first comment on that picture you got behind you. That's pretty cool. And for everybody that is listening, Vishnu's got this awesome psychedelic picture of the world map behind him that I've never seen before. And so you must be in a new place. But anyway, yes, to all of that, everything that Jacopo is saying, yes to that. And I want to know, but you speak about this disconnect between like the Ubers and the Airbnbs and the Googles of the world that are doing such large scale, and they're coming out with really well put together blog posts and in-depth blog posts. But then we've got everybody else that's trying to do this reasonable scale. Where do you see there are the biggest disconnects with like things that are normally over architecting our pipeline or our system when we're only trying to do reasonable scale?
Okay, so I'm gonna take a controversial example here, and it's about distributed computing, and it comes from again, being my first company on Spark, because of what was available. So and we work in e-commerce. E-commerce, for those of you who don't know, is a very high high volume type of data application, meaning that even a small e-commerce will generate like a lot of data compared to other applications, compared to the financial sector, for example. Maybe only advertising is more data intensive per revenue than e-commerce. So e-commerce is a very good benchmark for MLOps because it kind of stresses the system quite a bit. And what happened in the past, and what I did personally, was you have this distributed system to just do aggregation, counts, feature preparation before you train your model. And of course, that has worked well for the big data revolution, but in other sense, they kind of suck. I mean, coding in Spark for somebody that is not like an engineer that was brought up with the big data stuff is a massive pain in the neck. Like it forces you to learn new pattern that honestly you could totally live without. When it crashes, there's this gigantic error messages that nobody know what they're doing. There are at least 30 configuration in the setting of EMR, and honestly, I have no idea what they mean. Like there's all sorts of these things that are just like so painful to honestly do a group by and a filter. Okay, that's bad. I mean, it was necessary, but that's bad. Now take the like what we do now. What we do now, we have a system. We use Snowflake just for full transparency. We have a system that abstracts away all of that complexity. Now, I don't even know the Snowflake is a distributed computing because I just execute a SQL query, which for all I know, it may be executed on SQLite or Postgres or MySQL. And since all the aggregation and all the big data stuff get pushed down to Snowflake, when I get back my data to do ML, it's typically small enough that it can fit honestly on my laptop on a very small box in the cloud. Meaning, I don't have to deal with distributed computing anymore, even at e-commerce scale. I can build a recommender system without ever worrying about scaling horizontally. Okay. While of course that's not true for Facebook, that's not true for Google, that's not for Uber, and so on and so forth. All of this system that works at that scale, they don't really map to what we need. And given contemporary computing power and again, reasonable size of data that people have, there's really no reason for most people to have any distributed computing in their pipeline, which saves a lot of debugging, a lot of time, and a lot of expertise that can be used better by just doing our job. So I hope that that's like a practical example, which I know it's controversial, but I feel in my life, when I switched to handle distributed computation to not handle that, like it was a massive improvement in my quality of sleep and general happiness.
That's a bit of a hot take. It's awesome.
It's a hot take, but I think that with people like you saying it, and actually another article by Vicky Boykis comes to mind about she basically wrote this blog post called "You Don't Need Kafka," which I read, and I was like, okay, that's really interesting. I think that I'm hopeful that these kinds of honest discussions about what actually matters, will start to happen more because, from my perspective as a young engineer, let's be honest about where I learned, about what things I should know, and what things I should be working on. They come from job descriptions for jobs that I can't get hired for yet, but want to. So if I read distributed systems knowledge is a must, okay, well, I'm going to learn everything I can about distributed systems. And in my current job, I'm going to try and implement distributed systems so that for that future job, I can say, I know distributed systems, right? The second thing is, from blog posts from companies that, my company says we should be learning from, which is, as we've discussed, the Googles, the Ubers, the Facebooks, et cetera. And then third, I think is just like the overall zeitgeist, right? Which is where people, I think, hype up and talk about certain tools a lot simply because sometimes they're hard to use. Like I think sometimes, the reason that we have a lot of discussions about Kafka or Spark or some of these other tools, which aren't immediately coming to mind, is like, they're actually kind of hard to use. And I feel like I need to ask a lot of people how to do certain things. And as a result, the buzz just grows because it's like, oh, someone's saying something, I don't really know what it is. And so sorry for that little rant there, but my question to you based on that is, if in such an environment where sometimes our discussion about what we should be doing is kind of divorced from like what we talk about, how is it that an engineer at a reasonable scale company can like actually make decisions about what they should be doing and what tools they should be using?
So I think I think you should always work backwards from what is your final goal and what was your constraint. Like I'm gonna take again a recommendation just because it's something that people understand, as in everybody, even as a user of Amazon, understand what recommender system is. And again, and it's kind of this scale of like when there's a lot of data. So even if you're a small e-commerce, there's a lot of data that goes into that. If you think about that, you say, well, I need to make a recommender system that works for, I don't know, like a company making $200 million, like a year. Okay, so not Amazon, but still, like a pretty reasonable company. Okay, so this is the amount of user that I have. This is honestly the amount of prediction that I'm realistically going to have to serve. And this is the type of input data that I'm going to use and the type of model that are there in the literature. And then you work backwards and you say, well, what do I want to spend most of my time? And the answer at a reasonable scale is never, and I say never, and I'm going to say never again, on maintaining this. Like there's no value in the infrastructure at reasonable scale because somebody else is doing that better than you are. And honestly, it's not even a very interesting job. Okay. So my question then becomes, once I know that I don't want to maintain infrastructure, which tools do I use? Which services do I use to build my system, and where do I put my time? And my time is always in two things. First, data, making sure that data quality, the data is in the right format, data is, is properly built, so the data-centric AI kind of message, because there's a lot of domain knowledge that goes into that you cannot read from blog posts. Like the idea that there are, now this model that you plug and play into your use case and they're gonna work, that's false. That's super false. There's a lot of things about your case and domain knowledge, which is, by the way, the reason why you're building a strategic advantage. Like the strategic advantage is not so much in neural network ABC, is in how the entire pipeline, goes together, because you actually know what you're doing in that problem. And then the second thing I want to do is iterate on modeling. And I want to be in a system where iterating on modeling, again, is fast, is fun, and it kind of gives me the feeling that I'm progressing more than the model itself, which in many cases, it can be a simple architecture, of course, to start. And I just want to see the full things end to end. So that what I would do. Yeah.
That's great advice. I think the point about maintenance is crucial. It's so hard to get people, especially at reasonable scale. I think one of the things that you mentioned in your article, your blog post about it, which we'll link, and I encourage everybody to read and also check out, the Rexis paper on it, is that a differentiating factor between reasonable scale companies and unreasonable scale companies is the number of engineers that you can hire and that you can have. And the hard part at a lot of companies is, if you're building infrastructure that requires maintenance, it's hard to get people in the door that can then maintain that in the future, right? You have so much turnover nowadays. The engineering job market has never been hotter. It's very challenging. And I think that point about maintenance is really, really important.
Yeah, you're blowing the whole build versus buy question out of the water. Basically, for you, it's not really a question. It's how do we
buy everything, buy everything except the things that will make your evaluation or whatever is your metrics. My case as an entrepreneur, I always think about valuation of the company, but everybody is different. Like higher. That's where you should focus your effort in what makes the valuation of a company up. Working on data, which many people think is a kind of demeaning and boring job, actually in many cases, what makes the evaluation of the company goes higher, because now you build this moat, you build this barrier to entry, because you know so well the data about your space that if somebody wants to come in, it's going to take a while before they can even reach your maturity. So that's work that actually is worth doing for the company. Maintaining Kafka or scaling cluster or Spark, it really is not. Because if somebody's talented, he doesn't want to do that. If somebody is not, now you are a person that doesn't add valuation to your company. And again, you're not doing the best thing for the company growth. Okay, so just buy that and it's fine.
Makes a ton of sense. I wanted to ask a little bit about, just how the reasonable scale companies that, you've talked to, right? And how you were able to get to these repos that you created on GitHub that help demonstrate, what MLOps at reasonable scale look like. Can you tell us a little bit about how you actually got to the point of deciding that was something you wanted to do and what the reception has been? Because I think people in the community would really love to hear about that.
Sure. So we started, we have a bunch of friends and people in the community that are doing incredible stuff in the MLOps space. So for us, at some point, it was asking ourselves the honest question of, if we had to rebuild Tooso, if we had to rebuild our own company 4 years later, with all of our friends doing this amazing stuff, Snowflake came into our life, Metaflow came into our life, Prefect came into our life, what would we do? And so the answer to that question is that repo, which is not, and I cannot stress it more, is not a tutorial, a 10-minute tutorial on how you, deploy something on Fast API, deploy scikit model on Fast API. It's not that. It takes a while to get it because it's a template for a company, not a feature. You can literally build a company out of that stack. A company that processes terabytes of data and that use transformers for prediction. Actually, one of the recommended examples that you find open source is a transformer model for session-based recommendation, which if not super state-of-the-art, is still going to be top 0.5%. And you can train it and run it without any person involved. Because this repo kind of again, is this no maintenance, self-sustained kind of cycle. So that's why we started. And talking with people, and then once we get in live, we start talking with people at different companies. And we always got, everybody seems to kind of be happy about that and kind of resonate many of the things that we advocate for. Many people says, well, there's too many tools. So the reaction that the strongest adverse reaction I get, well, there's too many logos in that picture, and we don't want to learn all of that, which is fine. also there is kind of like an extreme version when you have, all this sophistication. You can totally think of like a smaller version to start, honestly. So that's one reaction. And the other point is that the many people have is, which I think is a nice point. I think is wrong, but is a nice question. Is a legitimate question. Is, doesn't it cost a fortune? Because at that point you're paying Snowflake, you're paying, let's say you're paying Prefect, you're paying, let's say you're paying Jeff, because Metaflow runs on AWS. So every time you run the GPU, Jeff goes to space, and so on and so forth. And of course it combines, it piles up. Like, I'm not saying that it doesn't. So it's a legitimate question. I think it's wrong because the most important cost of all is opportunity cost. It's not cost. So if I have to think about having people now doing what this tool do, now I have to pay people. Let's say I even have to pay me a bit less than what I pay Snowflake and AWS, let's say, for example. But now these people cannot use the time to produce something that's valuable for me, because now these people are just busy maintaining stuff for other people to be valuable, which is something that a reasonable scale I cannot afford. So I know that this costs a lot, and I know it's kind of a culture shift, but it's way better to spend in infrastructure than in people when people are not adding value. Way better. Way better. The other good point about infrastructure, that it scales like predictably, right? So if you copy and paste the template and you run it at 1 terabyte of data, it's gonna cost, I don't know, I never idea. Let's say it costs $10, whatever it is. Now, if I ask you, how much is gonna be 2 terabytes of data? Well, I can kind of just multiply that, right? So I can immediately predict, I just have to make a bit of calculation without different vendors, price stuff. But at the end of the day, it's a fairly trivial thing. Now, if I ask you, if you have 2 engineers and you add 2, how much your productivity is gonna go up? Well, honestly, that's impossible to predict. Even the best managers have super high problem in predicting that, because it depends on so many factors. So infrastructure scales better and takes away this opportunity cost, which is what I think we should avoid. And I think that's, I know it's a very opinionated view, but that's been.
It's funny you mentioned that about the scaling too, because one of the things that I was going to say right before you said that was how you also need to manage the people that are managing the infrastructure and all of that, and how dealing with people sometimes, I mean, it is rewarding. I love people. That's why we're in the community, and there are so many people in it. But when you're in a job, sometimes you just want to be able to say, do this, and then that thing actually does it. But with people, you don't get that always 100% of the time. And that was the point you made right there, right? Like, you can't effectively provision for how it will scale. And so I think that's a huge, huge point that you're making. Let's jump into one thing that you talked about in the blog post that I thought, or actually it was in the, you do so much that now I can't remember where it was, but I think it was in the talk, and it was around these 4 pillars. And the 4 pillars, especially, like, I know that people are going to ask about the ETL and reverse ETL and like how that pertains to the 4 pillars. And maybe we should just start with what the 4 pillars are for those who haven't actually seen the talk, and then go deeper into like ETL and reverse ETL.
Sure. So let's start with, so a new blog post is coming up soon on our TDS series, so about the 4 pillars. So just if you want, guys, just check it out. But just to give a brief of reference for everybody. So we have this kind of like philosophical principle, which it's as Groucho Marx said, these are my principles. If you don't like them, I have others. But it kind of summarizes what we learn from a more abstract perspective. The first one we talked about that, and I'm sure we're going to talk about more, which is privileged data work over model work, especially in the beginning. And for company reasonable scale, a lot of domain knowledge and a lot of the final performance of the system will come from better understanding and better treating data than for marginal improvement in model architecture. Marginal improvement in model architecture are more important at a later stage and are more important as you grow up, when marginal gain makes a huge difference. But in the beginning, they're not so important. The second point is what we call, ELT versus ETL, which is a very bad label, and I apologize for that. It was kind of a lazy pun of words. But the idea was, and it still is that we like data and the entire universe of a company data-wise. That is everything that happens to a company. Let's say again, sorry, you're building a recommender system. So there's a bunch of data that comes into your company. Some of this data you created yourself. Like every time you make a prediction, there's a new event. Some data comes from your target website, where people clicks on, where people buy, and so on. And you need to ingest all of that. Then there's catalog data, and you need to kind of all this data is what the universe of the company is. And our point of view is, well, you should kind of ingest all of this the way it is in somehow a very raw and unfiltered format, okay? As a log, as a it's kind of like, I wouldn't say a blockchain because that's a very loaded term, but it's kind of a ledger, okay? Which kind of keeps tracks at every millisecond of the history of this company, what happened inside this company, outside this company that is relevant for this company. And then you can use transformation tool like dbt, for example, like we use, to go from this continuous log to snapshot of things that you're actually interested in, okay? And these are the tables that then are gonna feed your BI, are gonna feed your ML model, and so on and so forth. But by clearly separating ingestion and storage from transformation, you can kind of sleep well. Because if I made a mistake in whatever transformation, or I want to do a different transformation tomorrow, the entire raw history of the word, my word, is already there. So I can just, destroy everything that comes after the raw data and rebuild all the snapshot every time I want. And so I get this nice stateless replayability of all my features and all my, BI visualization that is very hard to obtain with other patterns. So the way in which we kind of summarize it again in a bad label, but the idea is that store everything as it comes in raw, and then transform it with a replayable DAG later. And you're gonna massively improve the quality of your sleep again, I think. Does it make sense?
Yeah, I think that makes sense. I think what would be really helpful is, that makes sense in the ELT paradigm, right? Like that, especially as, and I think the crucial thing here is, as the cost of storage and the database and data warehouse systems that we have now are just like so incredibly performant, that makes more sense. But can you tell a little bit more about like why it was that we even did ETL, like what the historical perspective is for like why we couldn't do that, in a sense?
Oh yeah, I mean, so in our experience, so even at TUSO, which was again pre-Snowflake in Spark, we kind of still had this idea that you never overwrite things. Like kind of this idea that everything is always an append. There's never like a transformation into that. While in previous time, when you were still constrained by storage, but also the size of your example, your analytics workload, like you could run analytics workload only up until so far, there was kind of, this idea that you're going to keep the entire history of a product of a user may not be exactly effective, because now you can't really do the aggregation that you need anymore, right? But now this problem kind of disappear because of cost of storage and kind of computing is kind of going like super down. I think an example maybe between the old way and the good and the new way, so to speak, can be helpful. So again, let's say you're ingesting, because you're doing this recommender system, every day you ingest the product catalog, like the list of products that are like in the shop, right? So in day one, you ingest all the products and they have the price, okay? And then in day two, some items we're gonna change the price. And so in the old ways, what you're gonna do is that you're gonna extract the differences maybe, and then you're gonna overwrite the table of the products. So now the products reflect the last available price, which totally makes sense. So your tables stay exactly the same format. You're not going to spend more on storage, and your query going to be exactly the same performance as before. Makes sense intuitively. But in the new perspective, this is kind of wrong, because you're deleting the past in a way that is not undoable. Because by overwriting now the price that it was yesterday, now we cannot recover anymore. So a better pattern is that you store all the new prices, and then you have a transformation that says, well, this is the table with only the latest price for all the product, which is going to contain exactly the same information as the Postgres database in the first place, but without destroying the past. Why is that important? First, because you can always make a mistake, of course. But second, because in this Git way, you come into this frame of mind that you version data and events in the same sense as you version code. If you want to ask, what was the price of this product every day of the year for the last year, with this second pattern, you can do it in 5 seconds because you never destroy the information. It's just there. While if you keep on updating stuff because you're constrained by the size of the database that you can run, now of course all this information is lost, and you can't really answer that anymore. So I don't know if that makes it more like kind of practical as for people.
It was a beautiful example.
It's interesting
Awesome.
to me, like, because this actually came up in one of the channels in Slack recently in production code, and Laszlo, who everyone I'm sure by now is familiar with, was talking about how when you take these snapshots, then you can change the code, and then when you compare the new outputs to the saved snapshots and you decide on which one you want to use, there can be a lot of tricky, or what he called dragons, in the decision and comparing the new output to the saved snapshot. Do you have any best practices around that?
It was this problem about generic, like for example, the distribution of some value, or specific like row X now has a different feature than row Y, and we don't know why. Just so that we narrow it down to.
I think it was generic. From what I understood of the question, it's generic.
Okay, so I think, so one thing you should always do, dbt allows you to do it to a certain extent. Some dbt plugin allows you to extend the capabilities, is to test all the snapshots, so we call them, in a kind of programmatic fashion. So you just don't want to recreate snapshot because time goes by, or because you make a mistake, or because you change the code, but you just want to make sure that everything you do kind of respects some intuitive understanding of data. There are two types of checks you may run. One check is syntactic, and you should automate that as much as possible, which is syntactic. I mean, a column should never be null, which should never be null. Value needs to be unique when they need to be unique, and so on and so forth. But there's also semantic thing. People may check that with great expectation for, just to mention like an open source tool that does that, which pertains to the shape of the data, not so much this is null, not null. For example, is the mean around this value? Is this value always within this range, and so on and so forth. And if you work with your data like a lot, that you can kind of, after a time, you can kind of come up with reasonable expectation that will help you making those decisions. But in the beginning, and it's true, I do agree with that, there's a lot of data knowledge that goes into understanding, if the new transformation is quote unquote better than the old one. Yeah. But to my previous point, this is valuable work. I know it's not fun work, but this is valuable work, because once you figure it out, everybody else that needs to build the same recommender system will need to figure it out as well. And there's no, and it cannot speed it up. This is hard work. It doesn't matter how smart you are. You just have to put in the work to understand the data, which means it's a great barrier to entry. Yeah. Because if somebody's even smarter, cannot just do it because he's smarter. He has to put the same amount of work to get into working. So it's a good work. Yeah.
That brings up another point, which I remember speaking with, and also you still got to give us the next two pillars. Until that point, while we go on this tangent, I remember having Luigi Petruno on here, and he spoke about how he was really trying to create a knowledge hub and a process for when that work gets done, so then you don't have to replicate that work. Have you found a way to do that so that if one person does it, not everyone that comes after them has to do it?
Very good question. This is one of the biggest problem in data, like in that management of complex data pipeline, when at some point you end up with, maybe, 100 snapshots, or, all sorts of views and features and so on and so forth. And for us, I'd say it's still an open question of what is the best way to manage it. The problem for us is slightly tempered by the fact that we're a B2B company with a very specific set of API at the end. So we're not like Airbnb, which is probably, 2,000 models running internally, doing everything from price estimation to churn to whatever. We build models for a life, we actually sell APIs that do model. So the number of use cases that we have are fairly delimited. And that helps kind of keep this transformation a bit cleaner, because, it's not that tomorrow somebody's going to come up and say, hey, why don't we build new model X? that happens when we add feature, but it doesn't happen the same way as at Airbnb or Netflix. Somebody comes up with a new internal model, which may be every day of the year for what I know. We sell models, so for us, building a model always is a process of having an API, adding to our offer and so on and so forth. So for us, it's slightly easier than B2C companies. So one. Second, if you build a conceptually clean transformation that goes from raw data that requires a lot of knowledge, how data is ingested, how data is clean, and so on and so forth, to good intermediate table that instead are prepared by the people that know the raw data, but kind of abstract away all the details, then everybody else can just kind of work with the pre-made, standardized, and normalized data without kind of caring too much about what's before. A good example for us is all the academics and people that work with us and write paper with us. They don't really they never have to work with the actual data. What they do is that they work with normalized, clean, anonymized, fully encrypted table that has been prepared for them by people that understand everything that goes before. But from then on, it's just a data frame or whatever. Like from then on, it's just a clean, beautiful things to work with, and they don't need to worry about that. So there's still some good separation of concern you can enforce by building a good transformation pipeline, so that the people at the end of the pipeline don't really need to know all that goes into the first part. But how to do so, it's still more of an art than a science, and we have no particular recipe to share.
Yeah. So let's get into these other principles. What were the two that we're missing out on?
So one is, I think we talked to this, is like PaaS, SaaS, quote unquote, is better than IaaS. As in, again, if you can build infrastructure, build stuff that you don't have to maintain, it may cost you a bit more now, but actually, as we said, scales better and kind of remove the opportunity cost. So you're going to end up with a team that is much smaller, but much happier, much higher retention, because people don't do stuff that is not what they're supposed to be doing. And fourth one, which again, we touched already, was privilege vertical scaling to horizontal scaling when you can. As in good aggregation, good data warehouse, good feature design, plus a decent box on AWS will go a long, long, long way to build good ML models at reasonable scale. And then, of course, if at some point you inspire, please, do it. We did it. Again, it's not being against something. Is a very high additional complexity that I think many people don't realize it's unnecessary 90% of the time, if not more. I think we're so ingrained into thinking this big data kind of thing that we never made the switch of, well, but do we really need all of that? and the answer, I think is no. Like, if you want to train a transformer model in our, with our repo for recommendations, you find out you can train it without ever do distributed computing, and it's going to work like a charm.
So I just want to dive into that a little bit more and kind of say, like, okay, at what point, should a company, like, I'd like to understand a little bit more of the context in which a company has a sort of fork in the road, right? Where they can make the decision to go vertical and stay vertical, so to speak, or go towards this distributed sort of setting. What does that look like? And why do you think people are going down that distributed road, or at least it seems like more people are going that distributed road than they should?
So I think one is for historical reasons, and in the previous way, like everybody that kind of migrated to do ML a bit before the, nowadays, let's say 5 years ago, like my company was funded. I mean, the only way in which you can process terabytes of data was dumping that to S3 and then use Spark on it. Like, there was literally no other way of doing that. Then Athena came along, but it was a bit later than that. But 5 years ago, it was basically the only way you can do, select group by country would actually be with Spark SQL. Like, there was literally no other way of doing it, or the equivalent of that. Like, kind of like, there was no way of doing that. So I think there's a bit of legacy of people that started in that area, and now in the Snowflake era and so on, they're kind of, there's usual cost switching, new tools and so on and so forth. So this kind of resistance to adopt the new paradigm, because of course you build the other one, you don't want to throw it away, which is more of psychological than technical challenge. But you guys have been in this world, so enough to know that this is like a paramount. Yes, is a paramount, reaction of people. It's like, well, we built it. Why should we change it? And no, but because my perspective is refactoring is a state of mind. Like, there's no such a thing as an architecture that is done. Like, refactoring is your architecture, and you should always be able to change it and even turn it to the ground if needed to be. Like, don't get too attached to that, because it doesn't mean that it was bad. It was maybe the best thing you could do at the time, but then time changed, and so you should change with time. So, but that's, I understand, a bit more of an extreme version. So I think for people that really don't know if vertical computing is enough or distributed computing is enough, what I would suggest to anybody that doesn't know, I don't know, if transformer models are suited for that recommendation, start simple. You can always go build a transformer model down the road. Start with collaborative filtering. In this case, start with a big box in AWS. If you want to use Metaflow, is awesome. We use Metaflow. So start with that and see how much of your final goal you accomplish with that. Okay, without maintenance, without distributed computing, without patterns. It may well be that you can arrive at 90% of the accuracy goal that you have, or whatever goal you had, like that. And the marginal cost of adding another tool set, another people, a completely different way of analyzing stuff, it's just not more the money. So the vertical setting, even if you end up doing distributed stuff, start simple. Like, I think a point about our general repo and philosophy is not that repo applies to all companies, not even to the company reasonable scale. But if you don't know where to start there. You can always make it more complex, more distributed, more high scale. But for your first use cases, if you can fit your first ML in prod use case in there, there's something wrong with you because that obviously works. So start with that, and then take apart what you feel is constraining you. But always start with the simple things first, and then go to the complex one. Because now if you architect everything in a distributed fashion and you don't need it, now you're creating that massive decrease in productivity that you was even uncalled for. While the other way around is not a thing, because even by building a vertical solution first, you're still developing skills and intuition that you're gonna port to the distributed version.
Very helpful historical context, perspective. I totally see what you're saying there. And with that, and with our remaining time, what I would really love to do is very quickly just get into your perspective on where recommender systems are. I think we've talked a lot about, what MLOps at reasonable scale is like, and what machine learning engineers should be thinking about, as they're building systems for the future. But one of the things that's always intrigued me has been that recommender systems are I think, the most popular and visible application of machine learning in most people's lives. Can you tell us a little bit about what the state of the art in recommender systems is now, and what kinds of things are still problems in building Rexes?
Absolutely. So I think recommender system, yes, are super popular, as of course that you find them in entertainment, like Spotify recommends a song, in video like YouTube, and of course in any e-commerce you go, like if you go on Amazon, Walmart, and so on, you're gonna, like recommender system are now part of our life. I think they're like kind of like two tier of sophistication nowadays for recommender system. There's one tier for which I think the problem can be considered, I wouldn't say solved, but for which we made significant progress in making tools and best practices for that. And it goes into the, similar items, complementary items, collaborative filtering and all of that. The field now is mature enough that you can get awesome libraries out of the box that deals with all this, with edge cases, cold start scenarios, and so on and so forth. And it kind of gets you from 0 to 80 very quickly and in a very kind of like horizontal way. So if you know your data, you know your user, you know your feature, that is movies, products, whatever you're recommending, I think that there's a part of your work that is kind of already there to start. And then there's a second tier of recommender system, which are typically both, either super sophisticated or gigantic at scale. And then you find all this new part, which is the neural recommender system, which is still relatively new. And honestly, to my experience, they're not much used in industry outside of the usual, Alibaba, YouTube, and so on and so forth, because it's still kind of more of an art than a science to do neural rexes. So there's still like the building blocks are somewhat clear, but then how to make that work in an efficient way with a cost-effective, in a cost-effective way, I think that's still an open area of discussion, and then like an open area of research. If you go to rexes nowadays, most of the advanced recommender system are going to be neural related in some way or the other. But when you go out of rexes and you go in what people do, most people are using this first tier of solution, which have been proven to, sustain the test of time. They're very robust. They're very easy to implement. They're much easier to understand. And so there's nothing wrong with that. Again, remember the reasonable scale. The marginal gain for many people in having a neural recommender system versus a collaborative filtering one may not even be justified by the difference in cost in training. We had this paper last year of comparing simple product embedding, which is still neural, but shallow neural, session-based recommender with transformer-based recommender. And transformer-based recommender should have better, but it costs 8,000 time to train the transformer model than to train the Proctor model. If you make the calculation of what it a P3 large on AWS says, we publish all the data, so you guys can figure it out yourself. But the idea is that gain, of course, Alibaba is willing to pay for that amount of gain, because that's going to be billions of dollars down the line. It doesn't necessarily mean that it's cost effective or it makes business sense for everybody else. So I think there's this third thread of recommender system, which is people that are on the verge between these two. So they are sophisticated enough to go to the neural path, like we are, but not all their use cases, warrant that amount of marginal cost and marginal effort, which is very interesting, because now it forces us to. We want to do better than collaborative filtering, but we need to kind of use some ingenuity on how to make that better without spending too much compared to what we're going to gain. So I think there's a fairly interesting area of research and new ideas that can come from that. And finally, and just going to mention this, so if I can, there's a testing thing and robustness thing that my team is working on recently. We were releasing an open source library for that, which helps people test recommender system, because recommender system are very popular in our life, as you said, but also they're very scary, as a lot of bad things happen when you recommend the wrong things, or you do informational bubbles, or all sorts of things. So we need user to trust recommender system to not suggest stupid stuff. And I think a lot of the evaluation methods that we use right now in academia, but also in industry, are kind of this hit or miss thing, like hit rate or MRR, which do not really convey the full nuance of what a system does when you release it. And so my team is working with other people in academia. We're working towards this package, and will help people have a better testing perspective recommender system to build robust system that we trust a bit more. And I think it's going to be a more and more common theme now that ethics in AI and all these things start to becoming, rightfully so, mainstream discussion among practitioners. I think there's going to be an emphasis in how we become better at testing ML system in general, NLP, whatever, and recommender system in particular, because recommender system are so pervasive in our life.
Completely agree on the theory, the point of robustness, testing. These things they're incredibly important to do. We don't really allow any other software system outside of machine learning to go into production without rigorous testing, and yet somehow some of the machine learning systems that are in production don't have that level of rigor that we know we would like to apply. And I think a big reason is the tooling gap. And so I'm really happy to hear that your company is working on that. And I think that that's a really nice segue into, can you tell us a little bit about what Coveo, and I think maybe your division, which I think used to be called TUSU, actually does in the recommender system world, and what kind of problems you're working on solving?
Sure. So Coveo has 4 lines of businesses mostly. So website and workplace, which are less related to recommendation, but 2 that are very related is customer support and e-commerce, of course, right? And so the job of Coveo, or if you want TUSO or any other B2B company in the space, is providing a company with APIs and intelligence so that they can provide to their final customer the best possible solution to either their problem or their shopping intent. Okay. So again, we're a B2B company. We do not own e-commerces, but we give people that have e-commerces the mean to provide better experience with the customer. Okay. So our recommendation is both on content side. For example, if you're trying to solve a problem of why your AirPods do not work and you're looking for other context, then it's a content recommender. So you recommend other piece of content that may help solve a user use case. Okay. On the e-commerce side is the recommendation everybody knows is the people that bought this also bought that, or when you are in another cart, you try to give people complementary items, which is a much subtler problem than people think. Because, for example, complementary items like deeply shows an asymmetry that is not, there is not obvious in all machine learning model that we train for this. If I buy a TV, it's okay to suggest an HDMI cable as an add-on. But if I have an HDMI cable in the cart, it's very not okay to suggest me a $600 TV because that's probably a terrible idea. And this kind of asymmetry pattern, again, as you said, of robustness, are actually very hard to catch if you're not planning for that. So these are like an active area of research. And of course, session-based recommendation, which I would say are the latest kind of trends in the industry. It's a very big area for us. I mean, we publish extensively on that. We ran the last year SIGIR data challenge. We released the biggest e-commerce data set on the topic last year, and it's free for everybody to use. So session-based recommendations are really important. And it's the idea that you may want to suggest something based on what the user is doing right now. So instead of typical collaborative filtering where you would do, well, the user bought this in the past and what is going to buy, it's like what the user is clicking on right now and what is going to do next right now. And this is especially important in commerce because most people are not logged in. So if all your recommendation strategy can just get to people that you know before, that's work for Amazon, of course, or Rakuten, but it doesn't work for most e-commerce because people don't really log in until the last step when they want to buy. So session-based recommender, which are important for the big players, are actually subtly even more important in proportion, I would say, for smaller players, because they have anonymous user that don't come back very often. And so if you want to make a good recommendation, it's going to be in the moment, in the now. And there's a huge effort in the company in being better at that, and also with the community, open sourcing data, releasing models and so on and so forth.
So there's so many things that come to mind when we talk about recommender systems, especially one of our first meetup guests, Flavio, talked about how he had a recommender system that recommended the same item to every single person that went to the website for 18 days and they didn't catch it until somebody stumbled upon the fact that it was recommending the same thing for 18 days straight. And I tell this story all the time, just that why you should use something or why you should be monitoring your models and making sure that they are doing what they said they were going to do, but then also the dangers in machine learning and how easily things can go pear-shaped. What I wanted to ask you though is around kind of backing up and looking at the whole MLOps space as this ecosystem and how new it is and really how our maturity level right now, considering there are so many tools that are out there. You mentioned how many tools people say when they look at your one diagram, and that's like a fraction of the tools that are in the space. I think, so what I'm trying to wrap my head around and see if you have any takes on this is doing machine learning at a reasonable scale for certain use cases. Do you feel like there is at any time going to be like a stack that we use? And maybe it's different for different use cases there, where we say, you know what, if you're going to be doing a recommender system, you need XYZ to do that. And it's going to start becoming more and more apparent as we have people on the MLOps community meetup and they start showing their diagrams of their stack and they all start to look very similar. Do you feel like that is ever going to happen? Because I know you're an optimist do you feel optimistic about that?
Yes, I think there will be some consolidation in that, like it was in the data stack kind of it, right? So now everybody somehow agree that if you have tabular data or structured data, you know, 5 trans Snowflake DBT, it's kind of, again, it may not where your journey ends, very important, but it's where it should start. If you're just, you know, again, if you're just, you know, dipping your toes in the water. I think in the ML part, so if you imagine the pipeline, there's a first part, which is data ops, the second part, which is MLOps, right? So to speak, like the first part is about data cleaning, like, you know, aggregating. The second part is about training, testing, deploying. And the second part is still much more fragmented than the first part, at least in my experience and what I see in my friend's company and, you know, my network. And so I think there's some consolidation, you know, now there's a Cambrian explosion of life, you know, this life form. And then, like all evolution, some are gonna die, some are gonna grow and evolve into something better. Some are gonna die, and it's the natural dynamics of a thriving and, you know, also healthy community. So I know it's scary for people that come into the place to the space, and now there's like 1,000 things that you don't know where to start, which is why, you know, we went to the effort of actually evangelizing the field. Like, maybe this is not where it ends, but start with these 5, and then, you know, and then you can go and try out whatever stuff. But I think there's going to be some consolidation, but maybe not to the point of having end-to-end, you know, to having this, you know, like end-to-end platform that is like kind of does everything for Rex and so on and so forth. Because I think there's still many, again, compared to software, still many nuances in ML that in the next 5 years we're still not going to solve. And they still requires this kind of like trained eye how to, you know, do that, debug that. And the more we stress about robustness, responsibility, ethics, and so on, the problem we're gonna have more challenges, not less. Because for now, remember, the challenge for most people is how my notebook goes to production. But once all these thousands and thousands of new practitioners, you know, thanks to our repo, no, I'm kidding. Like they kind of put stuff into production. Now we have thousands and thousands of people that they have to monitor, debug, debias, understand this thing. So a new phase will start, which is incidentally is why we think it's important for people like us that went through the path, the reasonable scale path, and we achieved some sort of stability, to give back to everybody else and say, hey, we arrive here with these tools. And if you do this, you can arrive here. Because by doing this, we're gonna, you know, kind of make the level of the discussion of the field higher. As I really can't stand another blog post of like why 87% of model never go into production. I really can stand another blog post of that. We want to be in a community when everybody solved that, and now we can discuss interesting problems. We can discuss bias, ethics, monitoring, and by helping, hopefully, you know, we do our tiny part, but we're helping the community all together, by all together helping everybody else to, you know, raise the level of the discussion. We're gonna make ML more important. Because if we don't do that, and in 2 years from now, I'm still gonna get 87% of models don't get into production, this whole machine learning thing, guys, is gonna get another fall, or maybe not another winter, but people are gonna get tired of this, of promises that are not fulfilled. Not the Google of this world, they figured it out. Not the Facebook, they figured it out. But everybody else, if we don't help them figure it out, they're gonna get tired of this. And we're gonna get into another phase where we always say that was overblown, overpromising, and so on and so forth. There's a bit of hype, but there's also a ton of value that we can unlock. And I deeply, deeply, deeply believe that.
We speak the same language, man. And I think that's one of the biggest things that we try and do here in the community is make sure that everyone gets lifted up, and we're not creating those blog posts that are just how to deploy a model on the simple toy apps. We want something that has substance. We want the conversations that go deeper and they really get into what people are hitting up against. So I really appreciate that. I know that before we turned the record button on, you spoke about being an optimist, and you spoke about how stoked you are now at the current ecosystem that we're living in. Can you reiterate that for us to close out?
Of course. So it's a fantastic time to be in this field. Like, it's the best, you know, the best moment is really now. It's really the present. A couple of years ago, it was it was exciting for me. It was very, it was life-changing and life-shaping through my companies and so on. But it was also, honestly, a ton of hard work that I'm not sure I would suggest to everybody. Okay, there was also a ton of things that you have to figure out yourself, like all the pioneers in a field. When a field is very mature, it's a lot of things you need to figure out. Now we're still in this fresh, again, Cambrian explosion kind of field when all new ideas and things get thrown up. So it's still a very lively field, but it's much easier to get started. Like there's no more, you don't really need a PhD anymore to even build a recommender system, which was true 5 years ago, honestly, because to understand the theory and the implementation and so on and do that. Now there's enough best practices around some of these use cases and some of these tools that the barrier to entry is much lower, which is great. It's great because more people can come into the field. So again, if you want to start, this is a perfect moment. And it's great because the people that were already there, like myself, for example, cannot worry about stuff that I never like to do. I never really like to do infra or Spark or whatever. I can just work, what I really care about. Again, for example, testing, how do we operationalize robustness testing for X system? That's actually an interesting question. Way more than what is this Spark error telling me about my SQL query. So it's a fantastic moment to be, and please do reach out to any member of the community that starts here in this very moment. Please do reach out to senior member or people that are just older like myself and ask for questions, suggestions, and so on, because we're in this together and this is an exciting moment for everybody. And if we make a good job now as a community, I guarantee that in 5 years, nobody will ever say that machine learning was a hype.
Mm-hmm.
If we don't, we may go back to building web app, which I really don't want to do.
Man, I love talking with you. This has been insightful, fun. It's exciting to hear how you talk. You're obviously passionate about it, and you stick to the Italian stereotypes. You talk a lot with your hands, and it gets me really excited about everything that you say. So I want to thank you so much for coming on here, man. I also want to thank you for all these blog posts that you're writing and all these talks that you're giving. It's so nice to see somebody coming at it from this angle, and there's an obvious reason that it resonates with so many people. I think you're really hitting a nerve, so please do not stop, just keep going. We mentioned a lot of blog posts in this, we mentioned a lot of resources in this conversation, and we're going to throw them all in the description so that everyone can find everything that we touched on today. And if you're still listening, it would mean the world to us if you liked and subscribed and left us a review. If you're on iTunes or whatever, Apple Podcasts, if you're on Spotify, give us a follow. And if you're listening on YouTube, check out this shirt that I got, man. We're coming out with some merch for Christmas, and that is it. We've got the podcast wrapped up. Any last words from either of you?
I just want to say quickly.
Okay, so go. You first. I'm gonna do last.
Just want to say thank you. I think this was a really cool conversation because it was like simultaneously technical and also big picture. Like we got the historical perspective and we got to talk a lot about, what technologies make sense to users and not. And I think that's always a special conversation to have. So thank you for coming on, Jacopo. Thank you so much.
Thanks so much, guys, for having me. Again, two things to everybody listening. If you think we can help, reach out. We're super happy to, again, tell story and details again. Second, I'm just the tip of the iceberg, as in there's a lot of people doing all the work in the post, in our repository, and so on and so forth. In particular, I want to thank you, Luca, Patrick, Andrew, Andrea, and Ciro, of course. So there's a lot of perspective we bring into all this work, and they wouldn't be possible without their hard work. So there's as much responsible for this evangelization as I am. I just am, I guess, more handsome, so that's why I get to speak in front of the cameras. But that's just because of my good genes. But that's it.
Well, thank you so much, and we'll see you all later.
Ciao.